Let's see this question. This question is asked in GATE 2010 in the subject Signals and Systems. Given f of t equal to inverse Laplace of 3s plus 1 by s cube plus 4s square plus k minus 3 into s. If limit t tends to infinity f of t equal to 1, then find the value of k is. They are given options k equal to 1, k equal to 2, k equal to 3, k equal to 4. We need to find the value of k for the given expression. Okay, first write down the given function f of t is equals to inverse Laplace transform of 3s plus 1 by s cube plus 4s square plus k minus 3 into s. Okay, now we know that f of t is equals to L inverse of f of s. Okay, so for the given thing f of s equal to 3s plus 1 by s cube plus 4s square plus k minus 3 into s. Also given that limit t tends to infinity f of t equal to 1. Okay, limit t tends to infinity f of t is equals to 1. According to the final value theorem, this should be equal to limit s tends to 0 s into f of s. So according to final value theorem, what final value theorem states is, final value theorem, limit t tends to infinity f of t is equals to limit s tends to 0 s into f of s is equals to 1. Okay, now go for this. Limit s tends to 0 s into f of s. Now limit s tends to 0 s into f of s is equals to 1. So we have got f of s value this, so multiply with s and put it in the limits. Now limit s tends to 0 s into f of s value is 3s plus 1 divided by s cube plus 4s square plus k minus 3 into s. That will be equal to 1. Now in the denominator take s common. Now s tends to 0, s into 3s plus 1. If you take s common, it will be s square plus 4s plus k minus 3. That will be equal to 1. S gets cancelled. Now apply the limit value s tends to 0. That will become 3 into 0 plus 1 by 0 square plus 4 into 0 plus k minus 3 is equals to 1. Now in the numerator will be 1, denominator is k minus 3 equal to 1. So k minus 3 is equals to 1, k equal to 4. We have got the value of k, that is 4, which is the required one. In the options, option D is the correct answer. Okay, first you need to take the given equation as it is. Then we should know that f of t equal to inverse Laplace transform of f of s. So take down the f of s, and according to the final value theorem, limit t tends to infinity f of t equal to limit s tends to 0 s into f of s equal to 1. So apply this equal to 1 and taking the s common, finally we are getting the result of k as 4. So option D is the correct answer.